Welcome back, everyone. We're going to make a relatively quick video today, just talking about the topic of complex numbers, and in particular polar form, and how we can multiply, divide, and then use the Moivres Theorem with these complex numbers in polar form. First thing we'll do is we'll just talk about the formulas for how we do those three things, and we're going to do an easy example, just very, very easy, using some numbers in the formulas, and then we'll look at an exam question. It's only a medium, it's only an achieved, I think, but they do like to make the exam questions a little bit harder than just easy. So first of all, we have complex numbers in polar form. Let's say we've got two different complex numbers in polar form. We're going to call this one complex number 1, Z1, and it's got some R, we're going to call it R1, and some angle, theta1. And then we've got another complex number, we'll call that complex number 2, Z2, and this has got a different R, R2, and some different angle, angle 2. So two complex numbers. Let's say we wanted to multiply these two complex numbers, and we are in polar form. It's very, very easy formula. All it is if we want to multiply these two complex numbers, Z1 times by Z2 is just we multiply their R's, R1 times R2, we write the cis, and then we add the angles. And that's the whole formula. Just a reminder, cis stands for cos plus I sine. If you haven't already watched the formula about polar form, it might be useful to watch that. If we want to divide these two complex numbers, you may already have an idea of what's going to happen here. If I divided Z1 by Z2, we divide the R's and we subtract their angles. Theta1 take away theta2. R1 divided by R2. And the Moivres Theorem, I'm saying that wrong, I apologize, it's French, it's hard to pronounce. His theorem is now raising a complex number to a power. So let's say we wanted to raise Z to some power of n. Well, we raise R to that power and we multiply the angle by that power. Now that's just, imagine that you did Z1 times Z1, the same complex number. It would be R1 times R1, which was just R1 squared, so it's a power. And it would be theta1 plus theta1, which is just two lots of theta1, which is where we get this n amount of it. So it's just a direct implication of multiplying complex numbers. Repeated multiplying is our powers, so it's just using that rule. He gets a special theorem for it, but I don't think he did too much, taking it one step further from that Z1 times Z2. All right, let's look at an easy example. We're just going to put some numbers into these formulas. So in my example, we have got U is equal to 12 cis of 120 degrees, V is equal to 2 cis of 90 degrees, and first of all we want to calculate what U dot V, or U times V, sometimes we use a dot. So straight into his formula, U dot V is going to equal to the R's multiplied, I'll write it out, 12 times by 2, and then cis of my angles being added, 120 plus 90. And so that answer is going to be 24 cis of 210. Now it's etiquette, if you watched my video earlier on about the argument, it's etiquette to give this angle as a number less than 180. So if we just real quickly think about where 210 degrees is, well, 180 is the whole way around here, and so we've got an extra 30 to get to 210. 180 plus 30, 210. Instead, we're just going to go backwards. So remembering that the full length all the way around is 360, so the leftover would be 150. So instead of going forwards 210, we would be going backwards 150. So most textbooks would answer this as 24 cis of negative 150. Instead of going forward 210, we're going backwards 150, negative 150. All right, second one. U divided by V, just putting that directly into our formula, that's going to be 12 divided by 2 cis of 120 take away 90. Nice and easy. 6 cis of 30 degrees. Put my degree symbol in there. Lastly, if I want to calculate V to the power of 4, well, V, as you can see there, is 2 cis of 90, so this is going to be 2 to the power of 4 cis of 90 times by 4. It's using this Moivres theorem here. To the power, we raise the power to the r and we multiply the power by the angle. 2 to the power of 4, 2 times 2 is 4 times 2 is 8 times 2 is 16. And 90 times by 4 would be 360. Now, using the similar etiquette, 360 is a big number, and actually it's the full way around the circle. We can actually describe that as an angle of 0. So if you think about 360 degrees is the whole way around back to here, I could just tell you to travel a distance of 0 and you'd still be on that line. So this is how we multiply, divide, and raise to a power these complex numbers that are now in power form instead of in rectangular form. And one of the main reasons of why we, or how we use these rules, or even polar form in our topic of complex numbers at level 3, is mostly to do with raising powers. So you could imagine a question in an exam, hopefully you won't get this one, but you get given something like 5 plus 5i to the power of, let's say, 10. Now, without polar form, we would be expanding this bracket 10 times, like literally writing it as 5 plus 5i, 5 plus 5i, and we would need 10 of these. And that would be an absolute nightmare. So a technique we can use with this is we would need to convert 5 plus 5i into polar form. We could leave that as a little task for you to try. I'm pretty sure it'll be the square root of 50 cis of 45 degrees. And then we would just be raising that to the power of 10. And using Moivres theorem, that would just be the square root of 50 raised to the power of 10, cis of 10 times 45. So you can see how this could be very, very useful when we have big powers of complex numbers. We need another form. We don't want to expand it out 10 times. Anyway, that was a sidetrack. That wasn't supposed to be part of this video, but just thought I'd let you know. Last one, an exam style of question. This is still only an achieved question, but you can see it just jumps up a little bit from what we were just doing. So if u is q squared cis of 3 pi over 4 and v is q cubed cis of pi over 3, we want to know what u divided by v is. They want us to keep our answer in this r cis theta, this polar form. So we're using our divided by rule. We're doing u divided by v. So let's write it out. This is going to be q squared over q cubed cis of 3 pi over 4 take away pi over 3. So you can see a little bit trickier now. We're expected to simplify this, even though it didn't say it explicitly here. They just want it as r cis theta, not some fraction and some subtraction, just a single thing. So q2 over q3, there's two ways we can think about that. We could write this as either q to the negative 1, or we could write it as 1 over q. Either one of them is fine. Neither has a preference. At the moment, they haven't specified, and we would have cis of 3 pi over 4 take away pi over 3. I'm not sure if our calculators can do that straight for us. If they can't, we have to think a little bit about this. 3 pi over 4 take away pi over 3. We would like them to have the same denominator. I'm going to go for 12. Times top and bottom by 3, I end up with 9 pi over 12. Minus times top and bottom by 4, I have 4 pi over 12. So that was timesing by 4 top and bottom, timesing by 3 top and bottom. And then do the subtraction, we end up with 5 pi over 12. And that would be our answer. Alright, hopefully this was helpful. Thanks for watching. We'll catch you guys in the next video.